So what makes an atom of gold different than an atom of lead? So Dalton simply said that the atoms are different from one element to the other. However, it turns out that gold atoms, what makes an atom gold, are atoms that contain 79 protons inside their nucleus, whereas atoms of lead contain 82 protons inside their nucleus. In fact, to change lead into gold, in theory, all you have to do is remove 3 protons, which is exceptionally hard to do, and certainly costs more money to do than just to buy gold or dig it out of the ground. One of the things Dalton said is that all atoms of gold are identical and all atoms of lead are identical, but that's actually not the case. In the case of gold, some atoms of gold actually have 118 neutrons, but other atoms of gold can have maybe as few as 100 neutrons. So they're not really identical anymore. They can vary in the neutron count there by a factor of 18. So we have to be able to distinguish between these two different flavors of gold. And the way we do that is we use two numbers called the atomic number and the mass number. The atomic number, which we use the symbol Z or Z for, is the number of protons. And so all atoms of gold have 79 for their atomic number. In fact, that's what makes gold gold. If you look on the periodic table, you normally see gold written as AU, and above it you see that number 79. That 79 is the atomic number. The atomic number determines the arrangement of atoms on the periodic table. We see a number below that's actually the average mass of all the different isotopes, so more on that later. But for now, we need to distinguish between these two versions of gold, these two different isotopes of gold. And we do that by calculating the mass number. The mass number is A, and is equal to the number of protons plus the number of neutrons. And so our two different isotopes have two different mass numbers, so we'll call this one isotope 1 and this one isotope 2. So isotope 1 has a mass number of 118 neutrons plus 79 protons, and if we do the math, that comes out to be 197, whereas isotope 2 has a mass number of 100 neutrons and 79 protons. And so I think I can do that math. That's 179. So these are two different isotopes. And remember, isotopes are basically atoms with the same number of protons, so same atomic number, but different mass numbers because they have different numbers of neutrons. We need an easy way to be able to write this information down. So in the case of gold, we say the two isotopes are gold 197 and gold 179. And this is the mass number right here. So this is A. And gold, that's the element name. So all we do is we write the element name and then a hyphen, and then we write the mass number after it. Another way to do it is to use what's called the nuclide symbol. So we don't use that word very often, but that's the more technical word here. And the nuclide symbol basically comprises of 3 parts. X, which is the element symbol. So that 1 or 2-letter abbreviation for the element. And then we write the mass number up high, and we write the atomic number down low on the left-hand side. So in the case of gold 197, we would write it as AU, that's the symbol for gold. The 197 is the mass number, we write it up high. The atomic number we write down low. The atomic number for gold we saw was 79. And we can do the same thing for gold 179. So we write AU, we write the mass number up high, and we write the atomic number down low. So this would be another way we could write gold 197 and gold 179 respectively.